Hello, hello, hello. Good afternoon, good morning. Welcome back to this module 3 for data analytics course. Today we're going to talk about exploratory data analysis, usually called EDA. So we're expected to, at the end of this course, we are expected to learn uh, how to compute descriptive statistics such as mean, median, mode. Um, we are expected to understand what is variance and standard deviation. We are also going to explore the concept of correlation and the concept of distributions in our data set. We're going to perform univariate and bivariate analysis. We are going to try to understand what it means. Um, During this module, we're also going to learn outliers, how to identify outliers using different methods. And we're going to go briefly over how to ask questions when you're doing your EDA. What are the questions to ask? And how is it going to be data driven? Not just asking any questions, but specific questions that are driven by data or that will give us answers to our data questions. Uh, what is exploratory data analysis? Well, as it's written here, is a process of investigating our data to discover some specific patterns. These are specific patterns, though. Um, it's difficult to cite these patterns when we are looking at data from afar. The only time we get to know this, or we get to cite these patterns is whenever we dive deep into exploratory data analysis using some advanced methods. And EDA also allows us to spot anomalies, things that are unusual, things that we will say, oh, wait a minute, something is not looking good here. This is looking very unusual. So we call that anomalies. And we also use the test hypothesis, check assumptions, and for visualizations and summary statistics. So EDA is a very powerful um, concept in data analytics. After data cleaning, EDA is very, very important. We're proud to an EDA is a data cleaning process because you don't want to conduct an EDA analysis on um, or dirty data or data that is unclean. So in this module, we just use the clean market sales data set, the one we used in module 2, if you remember, uh, to perform our analysis. If you don't have that, you can run module 2 and use it to get your data set. Then that data set is all we're going to use for this module 3. Well, I believe this is going to be a very interesting time together, and let's dive deep together. The first thing we used to talk about is our environment. We've talked about why we import our pandas. NumPy pandas is definitely for data manipulation using our data frames on our data frames. At the other time, we talked about data frames and data series. I believe we understand the difference. Now, NumPy also we said is a mathematical engine that is used to do some heavy lifting for calculations. It's pretty much good for numerical operations and statistical functions. Now, we're going to introduce Matplot library, which is a uh, chart module for Python. We'll use it to plot basic charts and visualizations. Seaborn is much more a pretty type. So as I put it, Seaborn is more of an artist. Um, it specializes in statistical art like heat maps and color-coded trends. So it's a little bit more beautiful than Matplotlib. And SciPy, I'm not sure we're gonna use a lot of SciPy here, but let's see. But SciPy is basically a tool that is used for investigation. It helps us to check, to help us to understand the trend in our data. Uh, when we are carrying out hypotheses, we want to see, does this trend, is it just mere coincidence, or is it something that is happening in reality in the dynamics of our data? So all of these things, we're going to go through it once more. We'll call Pandas is the spreadsheet specialist. If you have used Excel before, which I believe most of us have, so Pandas is just like an Excel on steroids, like Excel that you have given a lot of drugs. It's working very optimally. So and NumPy is just for mathematics, and Matplotlib libraries for simple charts, showing axes and labels. Yeah, with that, we can dive deep. Do not mind this. This is just a way of putting some aesthetics in our chart. This particular one is to give us faint grid lines. It helps us to trace data points from the axis um, to help us to connect which data point and which number are they on the axis. Um, while this one ensures the plot.rc params ensures our chart looks consistent and uniform across uh, the uh, the notebook. So we're gonna load the clean data set uh, as I've established earlier on. Remember, we had a data set we worked on, Module 2. So we refer to it as market sales underscore clean. And if you don't have that, you can run your Module 2 again. And after you run your Module 2, then you upload it from here. So I already uploaded mine, and you close it. So the moment you upload it, you can now run it here. So when you run it, we get something like this. So what we have here is just we're checking the shape, which is a standard data check that we ought to make every now and then before we start any analysis. And here also we check for the columns that we have in our data set, and we change it to list. You have seen this method before earlier on. So now we're checking for the first five rows of our data frame by saying dot head. So it innately gives us row 0 to 4 when we call on dot head method. So that is aside. Let's dive deep into descriptive statistics. We start with central tendency, which tell us where the center of our data is. Uh, the three main measures that we are so much concerned with during our descriptive statistics for central tendencies are mean, which is the average, median, which is the middle value of our data set, and the mode, which is the value that appears the most. Um, so here is the formula for mean. We all know that it's the sum of all the values divided by the unique the counts of the value. Um, so this makes sense. The mean of our series of our data series makes sense only when the data distribution is symmetric in value. That means we don't really have extreme outliers, numbers that are extremely big or that are unusually big. then mean will make sense. But when we have outliers, we rather and we want to get the mean value, we rather want to use median. So median is the middle value when data is sorted. So half the values are below it and half above it. So it's more robust to outliers than mean, as earlier stated. So use these median when it's skewed. We'll get to understand what skew mean in the subsequently in this lesson. So mode is the just the number that appears the most in our series. Sometimes we have multiple modes or no mode at all. So for categorical data, uh, um, use for category data or you use it to find the most common value. So categorical data is data that is not numeric in nature. It's um take for example categorical data from our data set is talking about products like beans, yam, potato, but numerical values are ones that are integer in nature, float, integer or float, which is the price of the product or the total sales of the product. So categorical data are not you can't measure it with numbers, with um they are categorical. Just understand that. I'm sorry, I forgot the correct register I'm supposed to use to explain that, but I don't want to make a mistake. We can later on go and get some clarity concerning how what is the definition of categorical. But like I said, categorical values are usually values that you don't have. Numbers to explain. Like you can use a number a qual. Oh, I wanted to remember the quantitative and qualitative. So categorical values categorical data are qualitative, while um numerical data are quantitative. So take that as a very quick example of categorical data and numerical data. So let's start by selecting numerical column for analysis. So we're going to look into our market sales clean data set. So how do we calculate our mean? We just call dot mean on the series. You remember the last time I said when you call upon a particular column, you will be having a series, right? Yeah, so this is exactly what we're doing here. So here we specify before we do that, let's just look at what we have as our data again, data.head. So here we have categorical data here. This is the quantitative data, which is an integer. Um, these are integer, I guess, and this is also this looks like a float price per kg. This is definitely a float value, but we can always check it by saying data type. Um, data type. Um, just a minute. So, the way to understand if our data is either categorical, or continuous or qualitative or quantitative is just to check the data type. Uh, you say data.dtype, right? Um, that should give us the list as you see here, the data type that we have. So I was wrong the other time. Quantity is a float value. Price is a float value because it has a dot like a point 0.1. Anything that is continuous like that is usually a float. So a city is a string, which here we usually call object, and total says also is a float value. So that's just to correct my initial claim. Let's go back. Now that we understand our columns and the data types, now when we want to run analysis, especially mean, we are expected to run our mean on a numerical column. So that's why we want to specify on which columns do we want to run our mean method. So here we say we only want to run it on this, and this. So we exclude this, and this. Um, oh, now that we have specified the columns that we want to use, now we can just put it here, data into square bracket numerical columns dot mean. And when you run it, we should have the mean value for every column here. Um, there's one thing I want us to understand here. What if we have many columns and in that data set and we're not able to single-handedly or one by one, we are not able to pick them out, or it will take time for us to start looking for the numerical column one by one, one after the other. So there is a way we can actually do that. Uh, we can, let's see, just give me some moment. We can say, uh, for column in data.column, um, so this is going to go through all the data.columns, I mean, just the columns in our data set. So we say if the data column dot data type, the data column, so data column here, we go through all individual columns here, one after the other. That's what we're trying to do. So data.columns actually brings out the list of these. Then for individual one, we check data date, data product, data quantity. For data.column dot d type, remember we checked our d type the other time. So let's say data quantity, just for example, let's choose city dot d type. Sorry. City dot the d type. Mhm. So data city dot d types. supposed to give us an object data type, and if we want to try for quantity, um, make sure there's no space attached. So it's going to see, you see, it's going to give us float, right? Now, every time we check for the data, the column of the data type of the column of the data, we want to if data column dot dtype is equal to float 64, I guess. 64. No, I don't want to use. Or if data column dot data type also int 64, uh, we need to append something here. We need to create an empty list first. If you remember the way we did it the other time, extract new column equals to empty list. So we are just initiating an empty list here, and meanwhile we intend to append uh so extract new column dot append column. So if this is saying if when you check for the data type for every column that you go through, check for data types. If it's got to float 64 or int 64, which is the same thing as float value data type or int value data type, then extract new column dot append column. Then append that column. If this is true, append it to the new initiated list. So what happens after that? We should be able to see our, yes, extract, extract new column. Let's see what happens. Yeah. So now, provided that you have multiple, if we have like thousands of columns, we can just use this method to go through the columns, and we'll be able to extract the specific columns that we want to be working with. So now let's just call it numeric columns rather. Numeric, just to be consistent with what we have here. Column. So what if we want to make it more optimal? We don't want to type too long. We can also say if data column data type in, if you are comparing multiple value, you can just say in floats and also in int. Then close this. Yeah. So we should be able to get the same. Well, more importantly, what if we want to put this into a function? Let's say def. new column, extract new new column. We say our data is here. Then we say this. Uh, we say no. See for column in data dot column. If data column dot. Let's see what happens. They want it to return. One numeric column. Um, then we can say numeric column equals to extract new column data. Then we can say print numeric column. So what we did here is like we tried to put it in a function. We've done it before. Anytime we call this on our data, we supposed to get uh, this value, the specific columns that are numeric. So what we did is like we created a definition and we put the name of the function. We just wrap it inside the existing code that we had written before. And let's run it and see. Now we have numeric column is this. So we don't have to um, um, specifically, we just don't have to write it out. Uh, we can just call upon our function anytime we want to do this. So this is a very good way to apply what we have learned earlier on before this time in conditional statements and function to automate our work during our data science and data analytics processes. I know this is pretty much, it might be too much for you to, to digest early, but try and go through it several times and try and use it also, and you will see how you get to be expert going forward. Myself, I'm not an expert. I've done this maybe for a long time ago, so I'm trying to recover it. To the more you do it, the better you are, in short. So try as much as possible to go through it. Now that we have our numeric columns, we don't have, like I said, we don't really need to put it out here any longer since we have assigned it here. We don't Yeah, so anytime we need our numeric columns, we can always call on it and it should give you, yes, it should give you what we want. Now, if we run this, we should be able to get the quantity is the mean value of our quantity is 78. That is here, if you calculate all of the entries under quantity, and divide it by the number of rows, you should be able to have this number. The same thing with price per kg, the same thing with total sales. So how about our median value? We do the same operation we had on mean, we do it also on median. Just put the data, your data sets, make sure you specify the columns that you want to run the median method on, and run it. Doing this, you are going to get um several. This for quantity is 77. For price is two. The middle value is 272.5. For total sales, the middle value is days. So now let's go to mode. Mode, mode is typically doing a count, right? We are doing a count on that particular column and see how many times a particular number appear, right? So before we run our mode, let's just do something. Let's say uh data, let's say data 80 quantity kg dot value count. Let's count the let's count what we have there. So for our quantity, we have 20 uh quantity 20 appearing 15 times, quantity 74 appearing 15 times. Let's also check for uh our let's check for the city. So Joburg appearing 158, but on 156. So now let's, as you can see, if we check which one should I check again? Let's check for um, price per kg. Um, make sure there's no space there. You see we have 179 appearing 9 times and 429 appearing 9 times. That means we are tied. The mode has more than one mode for this price per kg. Our mode would have more than one mode, so we call it tie. Now let's just look at it first. Let's confirm if we run dot mode on the list of columns that we already established, what are we going to get? So it should be able to give us, yeah, you remember we had a tie here. So we had a tie, 179 and 429 for price per kg. And we have for quantity, I don't know if we had a tie. Let's check again. Quantity, uh, yeah, we have a tie also, 20 and 74. So that's why we're having it here. And for total sales, let's see if we have a tie. Yeah, we have a tie here. This and this. So that's why it's listing it out here. So for this one, we don't have a mode. For this, we don't have a mode. For this, we have 8910. Okay. Now that's all about mode. That's just aside that is not really very necessary. When we want to uh if for some reason we want to have a mode without tie, so we can just iterate through our numerical column, the list of columns that we are interested in. So for every column, we want to check that column, the mode for that column. Now, for the mode for that column, so for every response you have, the result you have from here, if you have more than one, like we have here, we have 2, 0, 1. If we have more than one result or response, That is, if it's greater than 0, if the length of the series here is greater than 0, it should print column, the name of the column. This is the name of the column, and the value, the first value of the series. This is just a way, this F print is just a way of filling in the blank. It says, hey, anytime you see a curly bracket, there's supposed to be a variable in it. Replace the variable with the name of the variable. So it goes here, it checks column, what's column? So the first column is quantity, right? It checks for quantity and it places it here. And it checks for mode value, mode var dot value, this guy here. Then it checks for the values, the first value. Uh, and it's this is just formatting it into a 2 decimal places. So, but it's saying if this is not greater than 0, then just say there's no mode at all. So here we're able to get the mode for the quantity, which is 20, the mode for price, which is 179, the first value, and the total says the first value, which is 4554. That is as simple as that. So this code here is just showing us the difference between a mean and median. So let me just give you a brief explanation. So anytime you have the mean to be greater than median, as we can see in this chart here, anytime you see your mean is greater than median, that means we have some extreme values that are that did not really appear so much, but is distorting the distribution of our data. So at that point, we will say the distribution is right skewed. So it's skewed towards the right. It's distorted towards the right. But when we have our mean to be less than the median, we say the data distribution is distorted or skewed towards the left. So we call it left skewed, and this is right skewed. So that is what we're having here. So for our data set here, we have uh, mean to be, that is data set for price per kg here. We are specifically checking univariate analysis. This is an example of a univariate analysis when you are picking, you're analyzing a single um a single variable in our data set. So we check for the mean, we check for the median, and here we are comparing it. If mean price is greater than median price, then it should tell us like this is right skewed. That is, some high prices are pulling the mean towards the right. So hell if it's less, that means some low prices, extremely low prices, but they are not really many, just a few of them, distorting our distribution towards the left side. But if our mean equals median, then we say the data set, the distribution is symmetric. That is, everything is on the middle line. The mean, the median, the mode, they are in accordance. They are in agreement. Okay. Um, yeah, before I forget, in the last session, I was supposed to show us this is just aside. It is not part of this course, but I was supposed to show us how to get take for example, we have we have data.product, right? So you have a lot of this. Um, but what if we want to check for just the unique values um in a particular column? Here we know we have a lot of repeating values. What if you just want to know the specific um products that we have without repeating? So that is when we use dot unique. Uh, it's a very important method that you can use to return just the specific uh categories that we have in our column. So that is a side. Now let's go to central tendency by product. Um, so we want to, this is a task that we have now. For each product, we want to calculate the mean and the median of price per kg. We also want to identify which products have the biggest difference between mean and median, and what might this tell you about price variability. So we are told to use a group by this and this dot arg. But you remember during our last lesson we used the dot arg somewhere. Let's just quickly go on go about it if we can see it. I think he's here. So we are going to use this method to solve this problem. Are we ready? If you are, you can pause the video for some time, then go and solve it. You can come back and let's solve it together when you've tried your own effort first. Now, welcome back. I believe you have tried to solve it on your own. It's very important that you try to solve it on your own, uh, so that it will give you uh, more confidence going forward. So let's call it I start equals to, so we want to say data dot group by, we want to group by product, right? And we don't want to use this. Group by product. Then we say dot have aggregation. Then we say price per kg. We say mean price. We don't want to use that. Say mean price. Yes, mean price equals which column do we want to run the mean on? We want to run it on price per kg column. And what operation do we want to do? Mean operation. We also want to check for median price, right? The mean and the median for the group by, the product that we have already grouped by. So median price is on price per kg, and what operation is median? What do we want to do? We want to reset our index. Reset index. This. Then we should be. Let's start by seeing what we have first. Okay. So this is the mean. This is the group bar. You see, we have only 1, 2, 3, 4, 5, 6 unique products. And we have the mean price for every unique product and the median price for every unique product. This is a very powerful way of aggregating. If you get to know this, it's going to help you so much. It's like pivot in Excel. Uh, So now we can go ahead and do like a difference, identify which product have the biggest difference. Uh, we can just do a difference between mean and median, right? So we can say price stats, uh, price difference. Hmm. Now we are trying to create a new column, right? By calling the name of the data frame, and we are inserting a new column name. Then we say price stats, mean price minus price stats, median price. Then if you check again, we have our differences here. So what we need to do now is to uh we need to sort, right? We need to sort this price difference. Um, we can say price stats, price stats. Dot sort value. Okay, sort value. Well, how do you want to sort it? We want to sort it by price difference. On which order we want to make it, and descending order. So we say ascending is called a false. Then we can say we can put this as price start again. Equals price start. So we want to assign it to this so that next time we can just call up price start and see what we have here. So now it has arranged it in a descending order using a price difference. Now we want to know identify which product have the biggest difference between mean and median. So since we know that this starts from 0, 1, 2, 3, 4, 5, so we can say um price test dot price difference index 0. Let's see what kind of give us. Well, I think we can just use iLocation. I think I forgot how to do that. So let's try to use iLoc. Um, iLocation is just telling us the integer location for our data frame. Yeah. So we can go and check for the. I was trying to use a series indexing the other time, but I think I can't remember how to do that again. Right now, I need to go and check it again. If you get to know it, or if you stumble upon that answer, you can just put it in our discussion so that we all learn together. But for now, let's just use this to get the products that have the biggest difference between mean and median, which is yam, and the mean price is 261, the median price is 251. So the price difference is 10 naira. Um, yeah, that settles it for mean media mode. So let's just go through descriptive statistics briefly. Our spread. Over time, you'll be hearing a lot of spread. So spread is just a measure of how dispersed our data is around the center. Um, Sometimes this happens in a different fashion. Sometimes it goes like this. Sometimes it goes a long tail, sometimes a short tail, and sometimes you have a very decent symmetric uh, uh, distribution. But when we have so many scattered data, sometimes it get dispersed and it's not symmetrical. And we do really want to understand that what is happening in that data. Um, so I forgot to answer this question. So what might this tell you about price variability? So it shows that the prices for yam is variable. Uh, it has a lot of uh, uncertainties. Maybe sometimes it goes very high and sometimes very low. So the deviation is high for yam as compared to other products that we have in the list. So that's just a brief explanation to that. So we have a lot of variability in yam prices. Uh, that's just a quick explanation.